So now let's get into a little 3D CAD speed modeling using Onshape. And this model here is called Clamp Fork. And there's always, more than one way to create a model in 3D CAD. But I think that there are kind of some common steps that you go through when you're trying to come up with a game plan, an initial game plan. And I think the first of those steps is to recognize where the origin is going to be located. And one of the first things that I look for is a bunch of dimensions that all seem to be coming from the same place. And I think in the case of this clamp fork, that place would be the center of this bore here. So 25 through with a little an opening here so it can kind of clamp together. So 25 through that hole there, you can see that we've got a dimension that comes down to the location of this kind of key feature down here. You've got a dimension that comes over to that same key feature. You've also got these dimensions that come down here to this key feature. Everything runs up through the center. You've got your height here coming from that location up to this height here. I just think that there's so many dimensions that are coming from that location. That's going to make a great candidate for the location of the origin. So the origin is going to be here. And then you can see here that on this side of the model is symmetric. So you've got this CLSYM, which means the model is symmetric. So what that means is that the origin is going to be basically right here. It's going to be right at the center of that hole. And it's going to be that radius 22. And it's going to be for the radius is a keyway. The hole's 25 millimeters, but the radius is that keyway, and then that tombstone. And then we're also going to have the origin right here, right at the center of the model. So it's always good to come up with a location of the origin before you really jump in and start creating the model. And then the next thing that you need to decide is kind of what your game plan is going to be for the order of your feature creation. And what I noticed about this model is that I could pretty much draw everything on the front plane. So I could create that tombstone shape. I could create this hole here. I could create the rectangle that goes through for the slot. I could even create maybe a center line here to give me the location of where this hole is going to end up being. And then what I could do is I could create this geometry here, again, all in that original sketch. I could create all that geometry in the original sketch, this circle here, this circle here, if I'm mirroring it or if I'm not mirroring it, regardless, I could have that all in that original sketch. Onshape seems to really work with an elegant solution when it comes to multiple contours. So it's definitely tempting to lay out the entire model, at least from one view in one sketch. In the past, I've been a little hesitant of doing that because I felt like the sketches got too complicated, but I'm going to give it a try here today and see how it works out. There's always more than one way to come to a solution in these types of challenges, but I'm going to give it a try here with kind of a layout approach where I lay out everything on the front sketch, and we'll see how long it takes us. So I'll start out by grabbing a screen capture of that challenge, moving it over onto my second screen, and then let's get into Onshape here. I'm going to be using the Onshape using my free account, which means that everything that I create in this demonstration is going to be available in the public space in Onshape, so you would be able to search for that. In fact, I'm curious if anybody has built this model yet in Onshape. So you can see here it's called 24-WC-20. So I go down here to public, and then I do search in public, 24-WC-20, enter, and oh, look at that. There's 1, 2, 3, 4, 5, 6, 7 different people in Onshape in the public space who have gone through and created this model. So this is pretty cool because it means if you're ever doing a challenge, a tootalltoby challenge, and you get stuck, you could just go into your free Onshape account, search the public space, and maybe you'll find somebody who's already got, the document created. You could click on that model, you could look through their tree, you could kind of see how they've created that model, and you could even right mouse button on that model and copy it into your own public space, your own space, so that you'd be able to actually work on it. So you could actually copy it into your documents. Right mouse button here, you see it says copy workspace, and you can just copy that right into your workspace. So it's pretty cool if you ever get stuck in a practice model. This is it's good to know that you can get in there and you can actually create that model. So LCR BrickTech says search for TTT parts, and that's mine. Nice, very nice. All right, so we're going to do create document here. We're going to call this 24-WC-20-clamp fork. That way anybody who wants to can search for it. This is going to be a public document. And here we are in the Onshape modeling environment. Let's bring up the keyboard cam so you guys can see all the fun shortcuts that I'm using, which is mainly just the S key, of course. And now we're going to start creating this model. We're going to maybe start out by going up here to options, workspace units, and just making sure that we're in millimeters and grams. That is my default workspace units in my Onshape profile. So most of the time I don't have to change it unless the model comes up and happens to be inches. So we'll go front plane, S key, begin a sketch, orient the view with the end key. And then we're going to go to the line command, single click, move our mouse down, single click again, move our mouse back, go over top of that line, move our mouse up this way, single click, and then we can let go of our mouse and we can come over to the number pad and we can type in that radius. So the radius is 22, enter. Then we can move our mouse up in this direction, single click, let go of our mouse. We can type in a dimension for that one. That dimension is going to be 45, enter. We can move our mouse over this way. Of course, this is going to be 44 because the radius was 22. So we can type that in if we want, but it's going to end up being driven. Hit escape. I'm going to right mouse button on that dimension, say change to driven dimension, and then I'll take this point and I'll press I, and then I'll take this center point here and this point and I'll press I, and that locks everything to the origin, gives me a nice black sketch. S key, circle, single click, move my mouse, let go, come over to the 10 key, 25, enter, nice. S key, center point rectangle right here on this centered plane. So that kind of sets me up with that center point. I guess that the width for this rectangle is going to be 6, and then the height is going to be, I mean, it could just be 45, right? We could just make the height 45, make it that same height to line everything up. And then we could just take this line here, this point here, press I, and lock those two together. So one thing that you'll notice about this print is that it's not center line symmetric looking at it from the front view, and the reason why is because of this counter bore. So this counter bore makes the front view here asymmetric, but if you look at all the dimensions, you quickly realize that basically everything else on this view is symmetric. So for example, this is 100, this is 100. You know, these holes here are both 33. The diameter here is 60, the diameter here is 60. The distance off center is 1/2 of 145. So you can tell that everything else is symmetric. So you could kind of like model the whole part symmetric and then go back and just add in that final feature that is non-symmetric. So that gives us that kind of opening there that we could clamp down. Here what we could do is begin sketching a line and then press the letter Q. This is something that I do a lot of times when I'm trying to do some layout work, if I'm trying to kind of put everything in the front plane. What I'll do is I'll create a dimension here of 14 for this dimension, and what that dimension is going to represent is the location of the counter bore. So that's going to represent this dimension here, this 14, which is to the center line of the counter bore. A lot of times I'll just put that in that first sketch to kind of help me lay out that first sketch. So now that I've got that upper region done, now I'm ready to sketch the remainder of this sketch here. So maybe I'll start out with a line that starts here coming off of this arc and kind of comes down at an angle. And, you know, at this point, you're just kind of doing your best to eyeball everything up. So this is going to come out and around like so. And then you're going to come off with another tangent line coming off of that. And then maybe a horizontal line to here. And then a vertical line. And I'll press Q to turn that vertical line into a construction line so I can use that to mirror. Now, sometimes what I do is I then go in and add in some dimensional information. Like this guy down here is going to have a radius of 30. And the distance from the origin or from the top plane, it's kind of nice. You could just pick the plane to that point there. Is going to be a distance of 100, and the distance from the center plane here, so again it's nice you can pick the plane to this point here, is going to be 72.5. So sometimes what I'll do is I'll kind of just add in a couple of dimensions at first, and then I'll go back through and start cleaning up the geometry. So like I'll take these two and make them parallel, so this here and this here, and the shortcut key for parallel is B. I don't know how you're going to remember that. I just remember it because B has like 3 parallel lines in the capital letter, but you know, you have to figure out a way to remember that. And then we could go here to our angle dimension. So our angle dimension from here to here is going to be an angle of 45. And then our final dimension from this plane down to here is going to be a dimension of 80. Now that geometry all looks to be fully defined or fully constrained. Maybe I'll add in another circle here, and I'll add in a circle like this, and I'll give this circle a diameter of 33. And now what I can do is I can select all that geometry. So just grab all that geometry there, including the center line, and then I can choose mirror, and that mirrors all that geometry over the center line. Now, sometimes you'll get a message like this, like select entities to be mirrored or select center line to mirror about. So you just go out on the screen and click it at that point. You can see that you're still in mirror mode. like the button is pressed down. That's what I use as an indicator. And then if I press escape, now I'm no longer in mirror mode. So that gives me basically everything that I need for the layout of the sketch from the front. The only thing that's really left over is that rib going up at an angle, but I think we're just going to tackle that last. So now what I can do is I can go to my extrude command. So S key extrude, bring up that menu extrude. And then what I usually do at this point is I just immediately press the space bar on my keyboard. And what space bar does in Onshape is it clears your selections. So it's going to clear out this selection. So I don't come over here and click this X. I just press space right away. And then I come out and pick the region that I want to extrude, that I intend to extrude. So maybe it would be this region here. And then I can press tab, whoops, it's not going through. Tab, get down to my dimensional value. So that's going to come out to a depth of 50, tab, space, and space is going to hit the check mark for symmetric. And then I press enter and that finishes that command. So now I can show that sketch again, and then I can S key extrude with nothing selected. And then I can just take my mouse out here over the region that I want to extrude, tab, oops, sorry, tab, maybe I should have done that first. Tab, and then I'm going to take that to a depth of 16, tab, space bar for symmetric. Another thing that you can do in Onshape that's pretty cool is at this point you can press shift enter. And when you press shift enter, it takes you back into the extrude command again. So now I could just, with my hands already on the keyboard, I could do tab, and then I could go down here to the depth of this last one, which is 33. And then I could do tab, space for symmetric. And then I could just pick this region here and this region here. And you can see how quickly we were able to get that geometry to become solid. So let's say I control Z, go back here to this sketch. Sketch is hidden, sketch is shown. I'm just going to show the sketch right away so that hopefully I don't have to show it again. And then I can S key extrude, and then I can tab, and I'm going to make this 50, tab, symmetric. And then I'll come out here and I'll click in this region. Okay, so now that looks pretty good. Shift enter, tab, 16, tab, space. And then I'm going to pick this region. Preview's updating here. And then I'm going to shift enter, and then tab, 33, tab, space, and then I'm going to pick these regions here. So you can see how quickly we were able to go from just having our layout sketch to having multiple features if we learned about that shift enter trick. And shout out to Airwick. I think I saw him using that in the tournament, and that's where I really learned how to do that. So that's the majority of the geometry in this part. The final two features that we have to set up are the counter bore and then finally the rib. So I'm going to save the rib for the end. There's one thing I want to mention about the counter bore. I've noticed in Onshape that I can come in here and I can create a hole. So I can go to the hole command here, and I could go to counter bore, and I could say I want this to be a counter bore with a diameter of, let's say, straight through hole with diameter of 12, and then with a counter bore diameter of 22 and a counter bore depth of 8. So I'm just using tab and the number pad to do that. But then when I go out on the screen and I click on this point, well, the counter bore is going to go normal to the direction of the sketch that we created there. And I don't know how to change that. If you're out there and you're an Onshape wizard and you know how to change that, please tell me, because I would love to be able just to change that. What I've been doing is just making a new sketch. So I make a new sketch here, and then I just drop a point right here, right at where that other point is, and then I exit that sketch, and then I use that point for the counter bore. So I go hole, I say I want this to be 12, tab, 22, tab, 8, tab, and then I go out and I pick on this point that I just sketched on that face, and then that gives me the counter bore in the correct direction. So that's how I do it. I don't know if there's a way to change that. I'm going to kind of keep an eye on the chat. PC Arduino says that's what I do too for the hole. Okay, so at least one person is confirming. Can be done by editing the mate connector. Yeah, I did kind of wonder about that. So let's learn together here with Victor K in the chat. So I'm going to hide this sketch of the point that I created. I'm going to show this sketch here. So another option that we have is we could go counter bore, and then we could go tab. We can make this 12, tab. We can make this 22, tab, 8, tab. And then here for the sketch points, instead of picking this point here, what I could do is I could select mate connector, and then I could take my cursor out on the screen and I can drop my mate connector on that point. So now we see it's going in the wrong direction. So now what can I right mouse button and edit that mate connector from mate connector, click to edit. Here we go. Realign primary mid axis, this line here. Oh yeah, it's just that easy, baby. Everybody knows how to do that. We've always known how to do that. No, that's very cool. So just click in there, click in there on the mate connector, click here to edit is what Onshape said. That's one of the things I really like about Onshape. Their tooltips are fantastic. So I did click here to edit, and then after I clicked in here to edit the mate connector, I was able to realign, click realign, edge of sketch, realign there, boom, and then we don't need that extra sketch of the point. Awesome. This is why I love Model Monday Live, because we can learn on the fly. We can all learn something by running into these challenges. And so that is awesome for all the Onshape users out there. All right, cool. So we took care of that one. So then the final challenge that we have here is the rib. And unfortunately for the rib, I couldn't find an answer for this one either. And so again, maybe we can lean on the chat. But basically what I would run into here is that if I created a line, and then I took that line and I chose to pierce it. So pierce means I want this line to be connected to that edge where the edge passes through. And it's Shift G is the hotkey for it, Shift G. Or you could click the icon up here on the relationships. So pierce, Shift G. So pierce is going to take place where this curve here is passing through the sketch plane. It's going to hook into this point here. So pierce. So it pulls that point. It took that point and it relocated it to wherever this curve is passing through the sketch plane. So now I've got a sketch representing kind of the upper edge of that rib. But now if I exit the sketch and I go into the rib command, I can't get it to work. So I go here to rib, I say this is my rib profile, and reverse the direction, and you can kind of see what the rib would look like if it was going in the upward direction. Reverse the direction into the downward direction, doesn't work. Extend to, so it doesn't work, can't get the rib to work in this manner. Now, one thing that I've tried in other CAD systems that has kind of let me get around this is I just put a little like nub here on the end. So just a little horizontal line up at the top to help control the direction of the rib. And so then what I could do is I can go into the rib and try again. And by the way, the reason this is happening is because what the rib is trying to do is it's trying to extend, move this back here, it's trying to extend infinitely in this direction. Because if we just had the rib stop short here, then we would end up basically with a 0 thickness. So I tried to have the rib extend beyond here, but when I try to have the rib extend beyond here, it doesn't really have anywhere to terminate, because when the rib extends, it's actually going to go right past this tangent edge, because this tangent edge is curving away. I demonstrated this pretty clearly in a video on ribs. So if you look at my YouTube channel, you can find that video about ribs. It's right in the thumbnail. It's really easy to find if you just browse through the videos. It says like ribs, but I'm talking about it in a different CAD system, but I kind of explain in depth what's happening with the rib command. So I'm not going to go over that again here in this demonstration, other than just to say that I tried that same workaround, and unfortunately I ran into the same situation. So, I tried to create the rib here using both of them, and it ends up failing. It ends up being problematic. Can't get the rib to complete here in this direction. Usually if you can't get the preview, it's not going to work. So, what do we do in that spot? Well, we don't, even though the drawing is calling out a rib, we don't have to force ourselves to use the actual rib command. What we could do is we could just, Ate is saying, what if you create an additional line in both sides? So you're saying if we created like something, like if we mirror this, let's see, I'm game. Let's see. So if we take this and make this Q, make this V for vertical. Oops, sorry, it's actually horizontal in this orientation. And then if we mirror that geometry, we still got a couple of minutes here, so I'm game for trying this. If we can figure this out, I'd be super happy. So let's say we create a rib and we say the rib is going to be this and this. See, that first one is what kind of errors out, which is kind of interesting. So let's say we did all these as like a rib. And flip direction. Nah, still not having any luck with it. Extend, using the option for extend profiles to part, not extend profiles to part. So still not having any luck with it. But the thing you want to remember is that, just because the drawing calls out for a rib, or the customer calls out for a rib or something like that. Whoops, I hit the hotkey for submit to support by accident. Even though the drawing calls out for a rib, or the customer calls it a rib, actually calls it a rib, you're not forced to use an actual rib command. You could always just go on here and create something like this. You could just create this geometry, put a little stub on there just so it's overlapping a little bit, and then just do a mid-plane extrusion. So you're never forced to actually use a rib, even though a rib is being called out. It's just being called out as a, as an indication of like what the common name for the feature is, but it doesn't mean you're forced to use that actual feature. So if we hit the green check mark here, boom, we created that rib. Sometimes the customer will say, I want this to be exactly tangent, but the reality is it's tangent to where it originally was, but that means that we end up with this extra little, almost like a keyway sticking out here. And so depending on how extreme that is, depending on what the radius of the arc is compared to the thickness of the rib, the customer may or may not accept that as a solution. That's a discussion you got to have with the customer. But when they give you a note that's just kind of like their vision of what this thing should look like, which a lot of times that's what you get from a customer, they say rib touches tangent to the arc. Just make it go tangent to the arc. Like, they don't actually care that can't geometrically actually happen. They don't care. They just want the thing to look pretty close to that. At least a lot of the customers that I've dealt with. So, you talk to the customer afterwards, you say, is this look good? And they say, yeah. And you don't even have to zoom in and show them that little flash spot. They're probably not going to see that in the manufactured part anyway. So that's my takeaway from this model, and that's how I would go about completing that model. I would definitely try to use the rib, and I will continue to try to explore the rib command in Onshape and see if I can find a way to use it in this scenario, because this scenario does come up a lot, and when I do find that, I will share it with everybody. But sometimes if you can't get it to work, you just got to keep plowing through. And so for this model, to finish this thing off, what I would do is I would right mouse button down here. I would say assign material. The material is going to come from the tootalltoby custom materials library. It's going to be plain carbon steel. Hit the check mark there. And then I'm going to go mass properties, and I'm going to come up with a mass here of 2906 grams. And so if we go back to today's presentation, let's see if we got it correct. 2906 grams is the correct answer. Let's go. We did it. So GG to Toby. And that is how you would go about completing that model. If you guys like those kinds of tutorials, be sure to hit the like button. Be sure to subscribe. Consider joining the channel. We'll have lots more great tutorials like that. And of course, if you've enjoyed this episode of Model Monday Live, well, it's not over yet. We're going to get into it now and show you the answer. But don't forget to like the channel. Don't forget to share and reshare. And don't forget about the value for value options we have. We always appreciate